This is a Palmetto Arms bolt and carrier. I intend to use this in one of the match rifles I'm putting together for this year's competition, if we ever have a competition. I've disassembled it into its component pieces. This is the bolt. This is a little jig, vise, whatever, that holds the bolt. The face of the bolt, of course, we have a firing pin hole, flat space where the cartridge head would rest, an extractor, spring loaded and it moves outward, and an ejector, which is a spring loaded plunger right here. Now that ejector is held in by a roll pin. I intend to remove the ejector. I'd like to put the bolt and carrier back together without the ejector in order to obtain some measurements for reloading. Now this is secured by a 1/16 inch roll pin. A 1/16 of an inch is 0.0625 inches. The punch has to be smaller than that. .057. Here's a Brownell's replaceable pin. 0.05. Come on, focus. .0595. So either one of these style of punches would work fine. Brownell sells these, and they're in these little punches. A lot of times you'll bend the pin. If it's a replaceable pin, you can replace it. If it's a punch and you bend it, you can straighten it, but it's never the same. I think the smallest, I'm not sure, that Brownell sells is this one. Very small. Now, when I release the toggle, the ejector pin was pushed forward and out, and the ejector retaining pin should be down this hole, and there it is. The spring is here. The components are such that here's the hole the roll pin goes in. The spring goes in the hole in the front of the bolt. And there's the ejector. It's normally held flush with the face of the bolt because it's being preloaded before the pin's driven in. That's why this little tool is nice. You can put the bolt in, and the plunger will automatically seat the ejector pin. What I do for competition shooting, I disassemble the bolt like this. And I want this thing at static position to rest flush with the face of the bolt, because I want to minimize the throwing of the brass. Competition firing line and shooters are about 6 to 7 feet apart. Sometimes maybe a little closer. And except for the left-handmost shooter, every other shooter on the line has a guy shooting to his left who's throwing brass at him. A lot of times you'll want to police your brass, and you don't want to have to go searching for it in the grass. So I'll trim the spring so that when I statically assemble this thing, this is flush, about flush with the face of the bolt. So that means cutting this much off of the spring. So after I get my measurements done, I'll show you exactly how to put it back together. This is the bolt I intend to use in the match rifle. You saw me remove the ejector spring and pin. This is an RCBS precision mic. For the most part, they're caliber specific. This is not part of the kit. The kit contains one anvil to accept a cartridge. And it's got a hole in the bottom in case you have a primer sticking out or something. So it sits on the base of the cartridge. Then there are two micrometer heads. Each head has a hole in the top of it. This one not quite passes a .224 projectile. This one passes the neck of the case, loaded or not loaded, but will not pass the case. I've coated the neck of this case with machinist bluing. I don't know, see that line around there? Not this big scarred area, but a little fine line the whole way around. That's the line where this micrometer head meets the case. Of course, meets it inside. And that's the datum line to establish the headspace measurement for 223. Now I've owned this for a long time, so it's hard to read. It looks like this case is 3/1000 longer than the SAMI headspace. I have some PPU ammunition here, loaded with 75 grain hollow point, supposedly matched bullets. So if I were to check the cartridge case recommended length, you see it's perfect. Well, it's a tad under zero, but not 1/1000 under. Now these numbers mean something. And the reason this one is 3/1000 longer than it should be is because this is fired from one of my competition rifles. And that particular rifle, the headspace is 3/1000 over optimum. Now I didn't chamber the barrel, but whoever did chamber it and made the bolt and the barrel extension ended up 3 thousandths over optimum. Well, that's fine. I think a no-go gauge is at 7 or 8 thousandths over optimum. But in order to minimize working the brass, I measure the fired cases, and then I resize them to no less than whatever, and I have a number for each rifle. So far the PPU looks really good. Now this number is totally arbitrary. If it has a meaning, I don't know what it is. Now this is the one with a small hole in it. Now this is actually 35 thousandths below the 0 marking on the anvil. But that's okay. So I measured from the bottom of the cartridge to the point where the bullet, it's not quite where it's seated at, to the point where the bullet engages the rifling. Well, what do I do with that number? Well, again, I don't do anything with that number. But I have this nifty little collapsible dummy cartridge. Now this shoulder doesn't touch the chamber. What's going to happen is this is going to go into the rifle until it touches the grooves in the barrel. And then it will collapse as I force the bolt home. With the gauge extended, I'll hook it under the extractor. Here we go. Now I'll put it in the rifle. Okay, I'm going to put it in the chamber. Slide the fully forward until the gauge collapses. Now this will be the length from the bottom of the cartridge case to the point where the rifling engages the bullet. I'm going to call that 154. A totally arbitrary number. I'll do it a couple more times and I'll average them together. If I seated a bullet such that it read 154 on this gauge, chambered in the rifle, the bullet would be just touching the rifling. My personal experience with the 223 is that the cartridge likes that. It doesn't want to be any more than 5 thousandths off the rifling. I'm not shooting hot loads. I work the load up from very light load until I get some pretty good standard deviations. They'll appear periodically as you increase velocity. Around 2,700 feet per second, I graph the whole thing. I pick the SD that's very low. And then that becomes my load. Now we know that this PPU match ammunition, and by the way, this is thousandths of an inch, but where 0 is, I don't know. I do know the PPU ammunition with the 75 grain hollow point boat tail match bullets is at minus 36 or something like that. Now the problem with loading for the 223 with a 5.56 is you're limited by the length of the magazine. In other words, I can't set the bullets longer and longer and longer, either trying to get to the rifling or chase the rifling as it erodes away, because I'm limited by the magazine length. I mean, the rounds have to fit in the magazine. Now, I was able to modify the magazine to gain 100,000ths of an inch. That involved cutting the face of the magazine out, removing a spring that was in here. I have to hold it. Well, this is missing. I used to have a tie wrap through here to hold the bottom plate on. If you've ever seen a high power match, you will understand what I'm talking about. If you have not seen a high power match, I'll provide a link in the description to a video. Half the shots, somewhere around that, are fired from the magazine. And for that, I use this load. You see that this is a factory load, and it just fits in the magazine. I'm 1/10 of an inch longer here. Half of the rounds fired in a match are singly loaded. And for the singly loaded rounds, I use this seating depth. And even with this extremely long cartridge bullet configuration, I've eroded the way the rifling on my 2 match rifles to where if I got this any longer, it would not reliably stay in the mouth of the case. And these are all 75 grain bullets. I don't know what this is. This is a 75 grain FMJ BT from Hornady. And this is no longer available. It's a 75 grain AMAX. It has a little bit of a plastic tip. But I don't care about the plastic tip because I'm inserting them in the chamber by hand. Now I assemble these match rifles and usually lend them to new shooters. And if necessary, I'll provide ammunition. If I provide something like this, I'll provide 3 of these 20-round magazines with each rifle, and 1 of these magazines which has a holding capacity of 0. I use these for single fire events where I just lay the cartridge there. If I supply hand loads, I'll furnish 3 of these magazines. I have a capacity of 8 rounds. And 1 of these. I do prefer MOLLE-coated bullets. Cuts down on the barrel fouling. And despite whatever else they claim, that's what it really does. Now these long loaded rounds, I loaded for my match rifle, which probably needs a new barrel. The life of a match barrel in high power competition, a 223 barrel, is probably around 5,000 rounds. The ones I've replaced have been, depending on the finances of the shooter, around 5,000 to 7,000 rounds. So the base to ogive length on this round, these rounds, is 165. So these would have to be set in to chamber in that match rifle have. While these short ones actually just measure 56. But because these are modified magazine length, I cannot lengthen them anymore. Now if you shoot a bolt rifle, single shot bolt rifle, or shoot a bolt rifle single shot, don't use the magazine, this is not a problem. Now that we've done all that measuring, we can assemble the bolt. It's just a little over 7/8 of an inch. Put the spring back in, put the ejector back in, and measure the static stick out. Reads 1/8 of an inch. So I want to shorten the spring by 1/8 of an inch. I'm going to do that off camera with a Fordham tool. I put a little bit of grease on the spring. I'm going to insert the spring in the hole. Now the ejector has a notch in it. The back here is not very long. The front is long. That notch goes towards the center of the bolt. And the pin goes through. The pin then limits the travel back and forth. Now, I'll make sure the extractor is lined up, and it feels pretty good. I have the pin in the starter tool. You want to drive the pin just below flush. Check to make sure it's not sticking out the other side. And then go ahead and assemble the bolt.